All right, today we're going to look at a new section. It's going to be a section that we hadn't done. It's going to be actually section 10.3 in your book. It's going to be find the area of regular polygons. So let's go ahead and get started. Okay, in this section, we're going to find the area of regular polygons. Now, we know how to do triangles. We know how to find the area of squares. But we're going to be finding the area of pentagons, hexagons, octagons, and so on. So our objective today is to find the apothem of a regular polygon. We're going to use that, that segment called the apothem. We'll learn how to find it, and we'll use it to find the area of a regular polygon. So let's review real quick. Our first thing in review we want to look at is what is a regular polygon? Well, for a polygon to be regular, then all the sides are equal and all of the interior angles are equal. So we're going to be dealing with pentagons, 5 sides, all the sides are equal, all the angles are equal, hexagons, octagons. Those will be the 3 we look at the most, focusing quite a bit on a hexagon. The next review thing we want to look at is a 30, 60, 90 triangle. We're going to see those quite a bit today, so we want to take a second to review the relationships those sides have. Remember, in a 30, 60, 90 triangle, we still have 2 legs of the triangle. We have this leg, and then the hypotenuse. And the leg opposite the 30 degree, so over here, that one we called the short leg. And the one opposite the 60 degrees we called the long leg. And so these had certain ratios. And just as a review, that if the short leg was 1, the hypotenuse was always 2. It was always twice as long. And the long leg was always radical 3 times the short leg. So our ratio was 1 to 2 to radical 3. And that was from short leg compared to hypotenuse compared to long leg. All that should be reviewed. We've done that quite a bit. So we've looked at those couple of things. We've looked at what a regular polygon is and the 30, 60, 90 triangle. Now let's look at the new stuff for this section. And let's look at a regular hexagon. So a regular hexagon, it has 6 sides. All the sides are equal, and all of the angles are equal. And we're going to come up with 2 terms here. The first one is going to be the radius. And a radius is kind of similar to what we do with a circle, is it's going to be the distance from the center of the polygon to a vertex. We call that the radius of the polygon, because basically what we're doing is we are circumscribing a circle around the outside of the polygon that goes through all 3 or all 6 of the vertices. So if you can imagine that green dotted line being a circle, then this segment is the radius of the circle. The apothem is a little different. The apothem is a distance from the center to one of the sides. And when we go from the center to that side, we go at 90 degrees. So we make a 90-degree angle between the segment that joins the center of the circle and one of the sides. So we call this the apothem of the circle. Okay, so let's fill that in for our notes real quick. The radius is going to be the distance from the center to a vertex. And the apothem is the distance from the center to a side. There's the 2 differences. All right, we'll work with the apothem quite a bit. And notice what we have here. We have a right triangle. And we're going to be working with that right triangle quite a bit, because we're also this other piece here, and I'll try and put that in black. This piece here, what would we call it? Well, it would just be one of the sides of the polygon. And then this segment here would be half of that side. So we're going to be working with this triangle quite a bit in dealing with the radius, the apothem, and then this segment being half the length of one of the sides. Okay, then let's jump here where we're going to find angle measures. So we have, trying to get it situated right, we have a 6-sided figure. Okay, so we have a hexagon, and we want to find angle 1, angle 2, and angle 3. Well, let's find angle 1 first. We've taken this hexagon, and basically this is the center of the hexagon, okay, the red dot here that I'm darkening in. So we would have to figure out what each of these angles would be. Now they're all going to be the same, so what would they each be? Well, remember we said that this is the center of a circle as it kind of goes around the outside of the polygon. And so how many degrees in a circle? Well, 360 degrees. And we have 1, 2, 3, 4, 5, 6 of these triangles. So we're basically taking this 360 degrees, which is all the way around, and dividing it 6 ways. So each of these angles right here, all of these angles in here would all be 60 degrees. So angle 1, which is the first angle we're looking for, would be 60 degrees. The next angle we're after is angle 2. And angle 2 is right here. And what do you suppose angle 2 would be? Well, angle 2 is just going to be half of whatever this central angle is. So half of 60 is 30 degrees. And now we want angle 3. And to find angle 3, we need to look at the triangle right here. And if I go redraw that up here and make it just a little bit bigger, we have angle 2 was 60. This angle, angle 2 was 30. Sorry, it was half of 60. Angle 2 was 30. That was 90, leaving us what left over for angle 3? Knowing that the angles all add to 180, 30 plus 90 is 120. If we take that from 180, then this angle here would be 60 degrees. So we can find certain angles based upon knowing how many sides there are. If there's 6 sides, each one of these angles is going to be 60 degrees. Now, I'm going to have you try one on your own. So given the pentagon, I want you to find angles 1, 2, and 3, assuming the pentagon is a regular pentagon, meaning all the sides are equal. 1, 2, 3, 4, 5. So I want you to enter into Educanon what angles 1, angle 2, and angle 3 are. And you may need to pause the video here to do that. Okay, so we said in the beginning our objective was to find the apothem, or to use the apothem in order to find the area of a regular pentagon. And so to do that, all right, so the green segment here is one of the apothems. Okay, and there's actually 5 of them. It goes from the center to the other side at 90 degrees. So what I want to do is I want to look at this triangle that we just made. And let's find the area of that triangle. Because if I can find the area of this red triangle, there are actually 1, 2, 3, 4, 5 of them. So I could find the area of this triangle and multiply it by 5. That would be one way to do it. So let's focus on just this triangle. The length from here to here, we're going to call it S for the length of the side, because all the sides are equal. We'll call this length here A, since it's the apothem. So the area of this triangle, this one triangle, is 1/2 times the base, which is this segment, times the height, which in this triangle, it's the apothem. So it's 1/2 times S times A. Okay, so that's the area of one of the triangles. Now, I know this has 5 sides, but let's say we didn't know the number of sides. Then we could say that the area of the triangle, or the area of the whole thing, I should say, the area of the, so this was one triangle, sorry. The area of the whole thing would be, we would take the number of triangles we have. So in this case, we have 5, but let's say we didn't know how many sides we have. We'll call it n for the number of sides. We would have the number of triangles times each triangle, 1/2 times S times A. Now here's where the formula comes in. The number of sides times the length of each side. So if we took the number of sides times the length of each side, That's the same thing as the perimeter. Because if this side were 10, 5 times 10 would be 50. So the number of sides times s is the perimeter of the figure, and that leads to this formula for the area of a regular polygon. It's 1/2 times the apothem times the perimeter of the figure. N times s is the same thing as p. And here's the formula we're going to use to find the area of a regular polygon. It's 1/2 times the length of the apothem times the perimeter of the figure. Okay, so let's try an example. And I'm not going to be able to draw this really well, so I'm not really even going to attempt it. Let's say we have a decagon. And that is really too much. All right, we have a decagon, so that would be 10 sides. And let's say that the length of the apothem is, we know that. Let's make it to be 12.3 inches. And let's say the length of one of the sides happens to be 8 inches. We want to know what is the area of the decagon. Well, we have 2 steps. Step 1 is to find the perimeter. That's fairly easy. It's 10 sides. Each side is 8 inches. So the perimeter is 80 inches. Step 2 then is to use the area formula. And the area formula we said was 1/2 times the length of the apothem times the perimeter. So it would be 1/2 times the length of the apothem, which is 12.3, times the perimeter, which we got in step 1, which was 80, and 1/2 times 12.3 times 80 comes out to be 492. Now we're dealing with area, and our labels are in inches, so it would be square inches. Pretty simple if we know the length of the apothem and the length of one of the sides. Okay, the last example we're going to look at is a honeycomb example. It says a honeycomb is made up of cells shaped like a regular hexagon. What is the area of a cell if the length of a side of a cell is 3 centimeters? So if we sketch a picture, we have a regular hexagon, and I'll try my best to draw it somewhat regular. Remember, regular means all the sides are the same length, and they're all 3. So we are going to work with this formula. We want the area of the cell. It's 1/2 times the apothem times the perimeter of the cell. Well, we can find the perimeter of the cell pretty easily. Right? The perimeter of the cell will be, there are 6 sides. Each of them is 3 centimeters. So the perimeter, the distance around, is going to be 6 sides times 3 centimeters each, or 18 centimeters. The trick here is going to be finding the apothem. And here's how we're going to do it. We know that the apothem goes from the center to the side. That's going to be the apothem. We also know that we have a radius as well. So what we want to try and do is try and use this triangle in order to find the length of the apothem. So what do we know? Well, we don't know R and we don't know A, but we do know the length of this segment from here to here. It is half of 3. It's 3, the whole length of the side, so this segment is 1.5. So what we have, I'm going to blow this up a little bit, is a right triangle. This is 1.5, and we're looking for the apothem. Well, we can't use Pythagorean theorem because we don't know what the radius is. But what we do have, and this comes from the very first example, is we know this angle right there. It is a 6-sided figure, so if we made this triangle, then this angle right here would be 60 degrees because it's 360 degrees around the circle. There are 6 sides to the circle, so each central angle in the middle is 60 degrees. Well, then that means this angle right here has to be 30 degrees. It's half of 60. which makes this triangle a 30, 60, 90 triangle. So the 1.5 is actually the short leg. We want the apothem, which is the long leg. And let's go back to that review. The ratio of the short leg to the long leg is 1 to radical 3. So the apothem, or the long leg, is the short leg, 1.5, times radical 3. So here's the point where we're probably going to have to go to our calculator at some point. Let's go ahead and go to our calculator and figure out the length of that apothem. So if we punch that in, and I'm going to go to 4 decimal places because I don't want to round too much, I get 2.5981 for the length of the apothem. So now we have everything we need. We know the length of the apothem, A. We know the perimeter of the figure to be 18. So the area is 1/2 times the length of the apothem, which is 2.5981, times the perimeter, which is 18. So if we multiply those all together, we get 23.3829. And you know Math Excel is going to ask you to round somewhere. Let's go to the nearest tenth. So in this case, it would be 23.4. Let's get our label. We're in centimeters. And since it's area, it would be square centimeters. So step 1 on this one was to find the perimeter. That was pretty simple. Step 2 was to find the apothem. And to do that, we had to work with a 30, 60, 90 triangle. And that's why we put that in the review for today. So if you're not sure on those 30, 60, 90s, go back to the beginning of the video where it starts with the review and make sure you have that ratio written down. Okay, so that's lesson 10.3 in your book. It's finding the area of regular polygons. And remember, our objective was to be able to find the apothem of a regular polygon, and we did that with the 30, 60, 90 triangle. If it's not given to you, you have to be able to find it. And then use that apothem and the perimeter to find the area of a regular polygon.